Hi, welcome to our class again, and we're going to be working on the area of a parallelogram using decomposition. So our goal for today is to find the area of a given polygon by decomposing into a regular polygon and using the formula of those polygons to solve for the area. Alright, so working on example number 1, how can you use the formula of an area of a rectangle to find the area of formula of a parallelogram? So let's think about of that thought or the idea in this lesson. So again, just to repeat, how can you use the formula for the area of a rectangle to find the area of a parallelogram? So look at a parallelogram. If you move the triangle to the opposite side, right? So it was here, right? We cut it, and then we put it on the other side, and with that you could make it look like a rectangle. So a rectangle we always know the formula by heart. It's length times width. Okay, so we know the formula for the area of rectangle is A, or the area is length times width, or LW. So how can a rectangle and parallelogram be similar? So look at the picture over here. This part of the parallelogram, we cut them and we move it here, remember, on the other side. So with that, they become similar because the areas are the same, and it becomes like the same length and width. This just like shape into slanted, not parallel to each other. All right, so but this one has two parallel sides. Here you could see that they both have two pairs of opposite sides and both are parallel, right, and have the same length. We could also say that the base of this parallelogram is equivalent to the length of that rectangular shape, and the height of the parallelogram is equal to the width of that rectangular shape. So with that idea, we could always say, or we can conclude, that the area of a rectangle is also the same with the area of parallelogram. That the length could be the base and the width could be the height. So we could now create a formula for the parallelogram. Area equals base times height. Okay, let's take another example. So this is a parallelogram. The base is 7 and the height is 4.5. Based on the formula, that's area equals base times height. So we could say, we could just substitute a value. The base will be 7 and the height will be 4.5, right? So now the area of this parallelogram, if you use your magical tool, 7 times 4.5, that gives you 31.5. And I want you not to forget the units of measurement. That's what we're always forgetting. So if we could put centimeter and centimeter here, so that's gonna be always square centimeter. If you're asking why is it square centimeter, just a little review of our law of exponent. So if you remember the law of exponent, we have, you multiply 2 units, it will be square units. So because originally this is 7 centimeter, right? We're just gonna put it here to see why is it that it's a square unit. So you multiply 7 times 4.5 gives you 31.5. You also multiply centimeter by centimeter, that's why it's square centimeters. So the area for this, let's say this is a garden or whatever is that has that kind of shape, parallelogram, is 31.5 square centimeter. Let's have another example. All right, example number 2. The pendant is in the shape of rhombus. A rhombus is a parallelogram with sides of equal length. What is the area of the pendant? This is the pendant. All right, so let's see how it is solved. Let's solve it together. So again, to read it, the pendant is in the shape of a rhombus, right? Or we usually call it diamond. But a rhombus is also a parallelogram, and we know that the area of a parallelogram is base times height. In this case, this is the height, right? So, and that height is 3. So now we got the area. The base is 3.8 centimeter. This time I'm gonna carry centimeter so that we know what units we're working on, right? And then the height will be 3 meters. 3 centimeter. Got it wrong. Alright, centimeter. So now we're just gonna multiply it with your magical tool. Let's see what your answer is. So 3.8 times 3 using your amazing tool called calculator is 11.4. And this is centimeter times the centimeter is square centimeter. There are 2 of them, right? You multiply. So now that is the area of that beautiful pendant that is in the shape of rhombus. Alright, let's look at example number 3. The area of the parallelogram is 72 square meters. What is the height of the parallelogram? Here we go. Let's see how we're going to solve this problem. So the area of a parallelogram, this is a parallelogram and it has an area of 72 square meters. We're looking this time for the height. So we're not looking for the area is already given. So we're still gonna need the formula that we have. So area is base times height. What we're gonna do is substitute the value for the area to find the other side, right? And substitute also for the base. So the area is 72 and our base is 12 and we don't really know what's the height. Using our knowledge on solving equation, we could always say that we could simplify it using whatever on the other side of the equation. So to isolate the variable h, which is our height, we need to divide the right side of the equation 12. Since we do that on the other side, we have to do it on the other side of the equation. So now we have 12 divided by 12 is 1. So h gonna be, let's see what we have. So we're gonna say that will be 6. And since the unit is meters, so we're gonna have to use meter. So now the height of this parallelogram is 6 meters. So every time that the area is given on the other side is missing, just substitute the formula if you have whatever formula you have, and just do the rules of equation, the rules of inverse operation to solve the problem. Alright, so with that, I would like you to explore the tasks that I have given to you in Google Classroom, in Savas Realize and Envision. So go check your Google Classroom, what work you have in there. So, okay, thank you and God bless, and you guys could start working. And if you have any question, just pop in anytime. Alright? Okay, bye for now. Until next time, everybody. See you. Good luck working on a parallelogram.